Right, students? Now the next problems are given like this. Convert each of the complex number given below in the polar form. I told the complex number is divided into 4-5 formats. Till now we completed complex form, polar form. What is meant by complex form? Just I will recall that. Z is equal to x plus iy. It is called as a complex form. This is a complex form or geometric form. Geometric form of a complex number. So in this geometric form of a complex number, if you using by argument, this is converted into z is equal to r into cos theta plus I sin theta. I told also one video how you will get a complex form. Z is equal to r into cos theta plus I sin theta. We will write it is in the short form also. Z is equal to r into cis theta, cis theta. C refers to cos theta, S refers to sin theta. This is I, this is r. So cos theta plus I sin theta. Z is equal to r of cos theta plus I sin theta is always called as polar form. Polar form, and it has the other names trigonometric form or modulus and argument form. Modulus and argument form, trigonometric form, polar form. Like that you have to remember z is equal to r into cos theta plus I sin theta. Now you should convert any given complex number. Given complex number is in this form, that means geometric form. You have to convert in this form. You want to convert in this form, you have to know the value of r. I told r is denoted as mod z in the previous problem. How you will get root over real part of z the whole square plus imaginary part of z the whole square. This is positive value of modulus, because modulus of a complex number is never negative, it is always positive. Next we need the theta value, because r we got it. Next we need theta. Theta is nothing but argument, you know very well. So theta is equal to argument of z. It is in first quadrant, we have to apply this formula. Otherwise I told depending upon the quadrants, formula will be little bit vary. Clear, students? So if you know theta value and if you know r value, replace here, you will get the geometric form converted into polar form. Let I will solve one problem, listen carefully. So given that z equal to 1 minus I. Now you can comparison, it is z is equal to x plus iy format. So x is equal to 1 and y is equal to minus 1. Now we need a mod of z, that indicates the r value. The formula is root over real part square plus imaginary part square. So the root over excuse me, real part is 1 square, imaginary part is minus 1 the whole square. Root over 1 plus 1, you will get root 2. This is the r value, r modulus of a z value. Next one, we need to calculate argument of z. Before, you have to see that this x value is 1 and y value minus 1 means argument of it is lies in which quadrant? Fourth quadrant. If it is fourth quadrant, I told argument of z is equal to minus tan inverse y by x. Why? Because it is minus theta. So write it here. If x is greater than 0 and y is less than 0, then z lies in fourth quadrant. So argument of z or amplitude of z is equal to minus tan inverse mod of y by x. Students, formulas you have to remember which quadrant and what formula we have to use. So theta is equal to, argument of z means theta only, minus tan inverse What is y value here? Minus 1 upon 1. So theta is equal to minus tan inverse minus mod 1 by mod 1 is 1 plus 1. You know, in the trigonometric table, tan inverse 1 is indicates as pi by 4. Before there is a minus. So you got theta value minus pi by 4 and r value is root 2. Now we can apply polar form. What is polar form? General formula? Polar form z is equal to r into cos theta plus I sin theta. Correct, students? So r value we got it here, root 2 into cos of minus pi by 4 plus I sin of pi by 4. Sorry, minus pi by 4. We got here argument is minus pi by 4. That's why cos of minus pi by 4 plus I sin of minus pi by 4. You can simplify more also. In trigonometry, cos of minus theta is plus cos theta. So cos pi by 4 you will get here. Here sin of minus pi by 4 is minus sin pi by 4. That minus will comes here. I sin pi by 4. Why? Cos of minus pi by 4 is pi by 4. That we will explain in trigonometry topic number 3. That time I will explain detailed. Clear, students? Now it is in the form of r into cos theta plus I sin theta. So which is called as a polar form of the given complex number. So first magnitude, next we have to calculate argument, substitute both. A magnitude or modulus is also called as r value. I told that. Clear, students? Right. Now fourth one. Let z is equal to minus 1 plus I. So z is equal to x plus iy format. Let what is x value here? X value is equal to minus 1 and y value is equal to plus 1. So now we are going to write mod of z. Modulus of a complex number is denoted with r. Formula is root over x square plus y square positive value. So the under root x value minus 1 whole square plus 1 whole square, which is equal to root over 2. That is r mod of z, which is equal to r is equal to root 2. Now we got r value. Next we need theta value. Theta is nothing but argument. See the this complex number lies in which quadrant? X value negative, y value positive. If x less than 0 and y greater than 0, then z lies in quadrant 2. Correct, students? X value negative, y value positive. Quadrant 2. In quadrant 2, what is argument of z formula? Pi minus tan inverse mod of y by x. This is the formula. So pi minus tan inverse mod of y by x means y value is plus 1, x value is minus 1. So pi minus tan inverse of mod of 1 by minus 1 modulus it becomes plus 1. So what is 1 value in tan? Pi by 4. So pi minus pi by 4, which is equal to 3 pi by 4. Correct, students? After making LCM, 4 pi minus pi, 3 pi by 4, this is only argument of z. We will denote it as theta. So now you got theta and you got r value. Polar form formula. Polar form z is equal to r of cos theta plus I sin theta. So you know the r value is root 2, cos of theta value is 3 pi by 4 plus I sin theta value is 3 pi by 4. This is the complex polar form of a given complex number. So I will explain one more problem, fifth problem. See the students. So let z is equal to minus 1 minus I. So you can comparison z is equal to x plus iy, x value becomes minus 1 and y value becomes minus 1. So modulus of a z is denoted by r. Its formula is under root x square plus y square positive value. So that is equal to under root x value minus 1 the whole square and y value also minus 1 the whole square, which is nothing but root 2. This is r value. Next we need to calculate theta. Theta is nothing but argument. Argument is depending upon quadrant. See that here if x is less than 0 and y is less than 0, then z lies in third quadrant because both are negatives. X value negative, y value negative. Argument is in third quadrant. What is argument formula in third quadrant? So argument of z, which is equal to theta minus pi plus tan inverse of mod y by x. So theta is equal to minus pi plus tan inverse mod of y value. Y is minus 1 upon x is also minus 1. So minus pi plus tan inverse of mod of minus 1 gets cancelled plus 1. So tan value in 1, tan inverse 1 means pi by 4. If you make LCM, you will get minus 3 pi by 4, which is called argument of a complex number. Correct, students? Now you got theta and r value. Polar form. Polar form, you see z is equal to r into cos theta plus I sin theta. Now you can replace these values. R value is root 2 cos of minus 3 pi by 4 plus I sin minus 3 pi by 4. We can do more simplification also. I told cos of minus theta becomes always plus theta. I will explain in trigonometry, that is sin of minus theta is minus sin theta. So you will get I sin 3 pi by 4, which is called polar form of a complex number. So one more question is given, sixth one. See that let z is equal to minus 3. Students, I told here imaginary part is 0. This is a purely real number. If it is purely real number, it lies on a real axis. Real axis will be there. I told its argument is either 0 or pi. When it becomes 0, if positive values are there, negative values are there, you are getting as a pi. So that pi value is argument, and always I told it is a pure real number. Its magnitude is equal to that complex number. Clear, students? Otherwise you can do usually like problem. Z is equal to x plus iy. You can comparison. X value is equal to minus 3. Why? Because this I can write minus 3 plus 0 into I. X value minus 3, y value is 0. So modulus of a complex number mod z or r is equal to root over x square plus y square. So the root over x square means minus 3 whole square plus 0 square. Root over 9. You are getting 3. Don't write plus or minus 3. Modulus of a complex number is never negative. So these are all the positive values of root over x square plus y square. You got r value. Now we need. So we got the mod of z or r value root over x square plus y square is 3. Now we need to calculate argument of z. Argument of z is equal to theta. Now it is you can see in the axis where it lies minus 3 comma 0. So minus 3 comma 0 is in negative x axis. So I told argument is lies always minus pi less than theta less than or equal to pi. Less than or equal to pi means so it is also including in the second quadrant. Correct, students? In second quadrant, what is the argument here? So you can see here minus 3 comma 0 lies on negative x axis. So the argument of z theta is equal to pi minus tan inverse mod of y by x. Now pi minus tan inverse mod y by x, y value is 0, x value is minus 3, 0 by anything is equal to 0 only. So tan inverse of 0 is 0, you will get pi minus 0 is pi. This is the argument of a complex number or amplitude of a complex number. Now polar form of a complex number z is equal to x plus iy, sorry, r into cos theta plus I sin theta. So you got the r value is 3 into cos of theta value is pi plus I sin pi. So replace theta value and replace r value in this formula, which is called polar form of a complex number. Now I can explain 7th and 8th, 2 more problems are there, I will explain here. Students, now 7th problem will continue it. So they are given, let z is equal to root 3 plus I. So we have to convert into polar form. What is meant by polar form? Z is equal to r of cos theta plus I sin theta, we have to convert. If you want to convert in that form, you have to know the r value and theta value. R is nothing but modulus of z, theta is nothing but argument. So I can write here comparison, this z is equal to x plus iy. So the x value is equal to root 3 and y value is equal to 1. So mod of z is equal to r. The formula is root over real part square plus imaginary part square positive, root over root 3 whole square plus 1 whole square. So you will get 3 plus 1, which is equal to root 4, that is equal to 2. So therefore r value is equal to 2. Now we need the argument. Argument means it is lies in which quadrant? X greater than 0, y greater than 0. So first quadrant, if x is greater than 0 and y is greater than 0, then z lies in quadrant 1. So argument of z, that is equal to theta, is equal to formula tan inverse mod of y by x. So tan inverse mod of y value is 1 upon root 3. What is 1 by root 3 value in tan tables? Can you recall it? It is pi by 6. So this is the argument. Now you got theta value and r value. So you know the polar form. What is meant by polar form? Z is equal to r of cos theta plus I sin theta is called as polar form. R value is 2 of cos of theta value pi by 6 plus I sin theta value pi by 6. So this is a polar form. So the last problem, we have the 8th problem. Solution. Let z is equal to pi. So by seeing this problem, here real part is 0. That's why it is a purely imaginary number. I told if it is a purely imaginary number, argument is plus pi by 2 or minus pi by 2. Plus pi by 2 means it is positive. Minus pi by 2 means it is negative. The last problem we had minus root 3. I told if it is purely real number, argument is 0 or pi. Positive means 0 number, negative means pi. Students, now we can comparison, it is z is equal to x plus iy, x is equal to 0 and y is equal to 1. Why? Because I can write it is 0 plus I, converting into x plus I format, correct or not? So mod of z is denotes as r, formula positive value of x square plus y square. So r is equal to under root 0 square plus 1 square, r is equal to under root 1, that is equal to 1. So r value we got it 1. Now we have to calculate argument. So it is I means where it lies on y axis, correct students? So you can see in the diagram. So I means it maybe lies in this quadrant. In this quadrant we have to take considering in the first quadrant. So what is theta value? Argument of z is equal to tan inverse of mod y by x, because it lies in which quadrant? Not in exactly quadrant, it lies on a imaginary axis, but it is positive only, not negative. Directly we can write pi by 2, otherwise you can substitute tan inverse of y by x. Y value is 1 by 0. 1 by 0 is undetermined value, that means infinite. So tan inverse of infinite value is equal to pi by 2. So this is an argument. So you got argument and you got the r value. So polar form z is equal to r into cos theta plus I sin theta. So you know the r value. R equal to 1 into cos theta value is pi by 2 plus I sin pi by 2. So finally 1 you can multiply also, you will get the same. So cos pi by 2 plus I sin pi by 2 is polar form of a given complex number. So these are all the problems in the second exercise, 5.2 exercise. Totally they will ask what is argument, what is modulus of a complex number, or how to convert to polar form. If it is given polar form, you have to convert into geometrical form also. How to convert? Just check it here. So this is given problem. Z is equal to cos pi by 2 plus I sin pi by 2. How to convert into geometrical form? Simple, students. Z is equal to cos pi by 2 means cos 90, 0 plus I into sin 90, 1. So z is equal to 0 plus I. So we got it I. Now it is converted into geometrical form. Correct or not? Clear, students? So one form to another form we can convert easily. So in PUC level you have only polar form or geometrical form. So in objective level you have Eulerian form. Euler form, e power I theta, those are all there. In objective level we will discuss it. So 5.2 is completed. This is only the complex numbers given in PUC. After that we have to go for quadratic equation. Quadratic equations you learnt in the SSLC. Now a little bit more on the PU examination, quadratic equations. Thank you, students.